All right, today we're going to take a break from electrical. We're going to talk about torque converters. Probably the most simple part of an automatic transmission to understand, but there's a lot of things to understand about them. A few things that can fail in them. There's only 4 main parts to know, and there's a few differences in different torque converters you can find in the same transmission. I've got some out of a 4L80. I've got this cut apart one out of a U760E. So let's talk about first things. We've got the impeller. Impeller is on the transmission side, but it's driven by the engine. It's part of the torque converter case. That is your drive, but it's also got your oil pump drive to it. It's going to drive the turbine. It's kind of like if you put a desk fan running in front of another desk fan. The one that's not running, the air blowing across it is going to make it spin. It's the same principle with a torque converter. The turbine is splined to the input shaft of the transmission, and they go together. One spins, it is going to send fluid into the other to force it to spin. Now, when fluid comes down, it's going to go in these fins and come down the bottom. It gets redirected back up into the impellers by the stator. The stator has its fins curved in a specific way to make that flow more or less efficient depending on the stall speed. Same with the angle of the fins. You can see it from the outside of the converter and from the inside, since we've got this one apart. That determines the stall speed. The stator has a one-way clutch. It's going to freewheel at coupling speed when both these are going the same speed, and during vortex flow, when you're got a lot of speed difference, you're trying to build up speed, that's going to be locked up. Then there's the torque converter clutch. Big friction disc in there, and a big drum pushes against it. When you've reached coupling speed and the transmission controller has decided it doesn't want to use a torque converter anymore, it just wants a 1-to-1 ratio through the transmission, it's going to apply fluid pressure to this part, this big drum, and lock it up. This is what failed in this converter, is the friction started slipping. This one, the friction's now fallen out. Torque converter also drives the engine, the transmission oil pump. So when you're installing it, you have to get the oil pump splined in, the stator splined in, and the input splined in. If you don't have them all seated, you will probably break the transmission oil pump. Now, the 2 flow types, vortex flow and rotary flow. Vortex flow is kind of what makes a torque converter really work. You have the impeller spinning, and the turbine not spinning or resisting wanting to spin when you're trying to accelerate away. Fluid flow is going to go out of the turbine, out of the impeller into the turbine, force it to spin. Then it has to come back through the stator, get redirected back up into the impeller, and it just keeps doing this on both ends all the way around. That's why we call it vortex flow. Rotary flow is just the act of fluid being thrown outward around the diameter of the torque converter. You're spinning it, fluid wants to go to the outer diameter. That happens just naturally with speed. Where they happen, vortex flow is happening while the converter is wanting to accelerate, while it's wanting to build torque. Rotary flow, your impeller and your turbine are close to the same speed. It's not really converting a lot of torque anymore. All that action has slowed down and fluid's just kind of free floating in the converter. Now, diagnosing a failed converter. If you're trying to accelerate away and it feels like the converter is not doing anything, or you do a brake stand and it just revs up, the one-way clutch in the stator may be broken because the redirection of fluid in the converter is not happening. It's allowing this to just free spin, and it's not actually locking and redirecting that fluid flow. You might have a bad stator, not allowing that fluid flow to redirect. The one-way clutch, like we've talked about, can be failed. You go into torque converter lockup, and it might make the car shake. It might feel like you're driving over rumble strips in the country. It's probably the best symptom I can think of. And yeah, now for race converters. Not even just race converters, even we can see here, I have another video on this. I'll link that up here. They'll have different stall speeds. Let's go over that again. The fin angle of these two torque converters is very noticeably different. And that's going to greatly affect the stall speed. That's these fins in here and in here. The angle of those fins is a big factor in stall speed. The other thing that affects stall speed a lot is the stator. The angle of the fins in the stator, the amount of fins in the stator, and basically how well you can see through the stator. Because if you can see well through the stator, fluid's going to want to pass through and get right back into that vortex flow. That means it's going to be a quite low stall speed or a lower stall stator than if this was more closed up. So on some race converters, you can get what's called a bolt together converter, which allows you to basically do what I've done to this one and take it apart at will. And you can often buy different stators to change your stall speed whenever you've got the torque converter out. Might be something you even do at the racetrack. Hope you learned something today. Like, subscribe, comment, let me know if you like what you see.